Alright, ladies and gents, we spent a while trying to factor polynomials, but now we're going to try and determine if an expression is a factor of a polynomial. This is going to lead us to being able to factor really, really big, complicated polynomials, so just bear with us. So, a expression is a factor of a polynomial if we divide it into the polynomial and the remainder is 0. So if there's no remainder, that means it is a factor. So for example, I want to see if this divisor is a factor of this polynomial. So if I were to divide this into this polynomial, the remainder should be 0. If it's not 0, that means it's not a factor. So you can either do long division or you can do synthetic division. I'm going to choose synthetic division just because it's quicker and easier, in my opinion, of course. So I'm going to set up my synthetic division bar. I'm going to bring down my constants, my coefficients down here. So we have 1k cubed, negative 1k squared, negative 1k, and negative 2 as a constant. And my divisor is going to be a positive 2. So just like we've been doing all this time, we're going to take it step by step. I'm going to bring down the 1. Oops. Bring down the 1. 1 times 2 is a 2. That's going to make this a 1. Because negative 1 plus 2 is 1. Plus 2 again, because 1 times 2. 1 times 2 is 2. Combine these two to get 1. 1 times 2 is 2. The remainder is 0. Since the remainder is 0, k minus 2 is a factor of k cubed minus k squared minus k minus 2. Let's try this one. We have b to the 4th minus 8b cubed minus b squared plus 62b minus 34. And our factor we're testing is b minus 7. So I'm going to set up our synthetic division bar. Remainder. If the remainder is 0, it's a factor. If it's not 0, it's not a factor. Our divisor is 7. 1b to the 4th, negative 8b cubed, negative 1b squared, 62b, then negative 34 as a constant. Bring down the 1. 1 times 7. 1 times 7 is 7. Negative 8 plus 7 is a negative 1. Negative 1 times 7 is negative 7. Brings a negative 8. Okay, here our remainder is 8. So that means b minus 7 is not a factor. Okay, so if our remainder is not 0, that means it's not a factor. If it is equal to 0, that means it is a factor. Okay, that's basically all there is to it. We got some problems to test out in a second, but that's all we're doing for this one. Just testing to see if it is a factor. Alright, for homework, I want you to finish these problems. You're basically just testing to see if it is a factor. So if your remainder is equal to 0, it is a factor. If the remainder is not 0, it is not a factor. And we already did the first two before, so don't have to worry about those.